Alright, this is video number 2. It's just a continuation of the 6.3 packet. And we're going to look at a couple more exponential functions. So the next one we're going to look at is y equals 3 to the x power. Now, because this is my b, I already know that this is going to be a growth graph. And so I'm going to do my table of values, my t-chart. I'm going to make it over here. X, Y, I'm going to use the same numbers we've been using because these are the easiest numbers to work with. And I'm going to calculate each of them one at a time. And this will become 1 over 9. This will become 1/3. This will become 1. 3 to the 1 power is 3. And 3 to the 2nd power is 9. Those are my table of values for the function y equals 3 to the x power. Remember, these are not the only 5 points that exist on the graph. There's an infinite number of points. This graph goes forever. But these are the easiest 5 to graph. So -2, 1/9, that's way down here. It's just barely above the y-axis. And then -1, 1/3, that's also just barely above the y-axis. Then we have 0, 1, that puts us there. 1, 3, now we start to get a little bit of movement. And then 2, 9. That's going to be way up here. So there's like our first big jump of the exponential growth function. And if I had put 3 here for the x, think about what 3 to the 3rd power would be. That'd be 27. So that's a huge jump that would happen on the next x value. But we don't have enough room. That's another reason why these are the best 5 numbers to pick for our x's. We connect our points. We know it's going to go up and to the right, and remember, it's going to come down, but it's going to stay just above the y-axis. These numbers will continue to get smaller and smaller as we go to the left, and they'll get closer and closer to 0, but they'll never actually reach 0. And so our domain and range, you could probably starting to see a pattern here. Well, x's can be anything, so it's all real numbers, and this time I'm going to use the symbol for numbers. And then for my range, it's still all the y values that are greater than 0. So there's that graph. And now we'll go ahead and do another decay graph, which means my b value is between 0 and 1. And we're going to do y equals 1/3 to the x power. Now if you remember the first 2 graphs we did, we had y equals 2 to the x, and then we did y equals 1 over 2 to the x. Well, we're going to follow that same thing here. We started with y equals 3 to the x down here. Now we're going to do y equals 1 over 3 to the x. So because this b value is between 0 and 1, I know it's going to be decay. I know it's going to go down and to the right. So if I make my t-chart this time, you'll recognize the values we're going to use are pretty similar over here. It's just going to be flipped. So I have -2, -1, 0, 1, and 2. And now as I do this, and I'll plug in the first one so remember what we're looking at. If I do 1/3 to the -2nd power, I flip the number on the inside because the negative exponent, and it becomes 3 over 1 to the 2nd power. Well, that's just 3 to the 2nd power, which is 9. And then it continues the same pattern we had over here. I'm just going in the opposite direction. The only one that doesn't change is the y-intercept. Notice how y-intercept is 0, 1. This y-intercept was at 0, 1. This y-intercept was at 0, 1. And this one was also at 0, 1. Do you think you know why that might happen? Well, the reason that happens is because the y-intercept is based on the a value. So go ahead and write that note down here. The y-intercept occurs at the a value. So in all these graphs so far, our a value was the number in front of the base, which was just 1 on all of these. Well, if we continue our table now, this one's going to be 1/3, this one's going to be 1/9. And I'm going to go ahead and graph these. -2, -9, now we're way up here. It's just kind of the mirror of this one, right? Everything's just flipped. So we're going to be at -1/3, 0, 1, 1 1/3, and 2 1/9 way down there. So now I'm coming down and to the right and going along the y-axis. approaching 0 on the y-axis but never touching it. My domain is still all real numbers. And my range is still all y values greater than 0. Because remember, while it gets really close to 0, it'll never actually reach it. All right. Hey, what happened? Nothing. Don't worry about it. You're actually going to open up a new tab in your internet browser, and you are going to Google search for Desmos. And we want to go to desmos.com. And when we get to desmos.com, you're going to click on Graphing Calculator. This is a really good tool that we can use when we are checking our graphs. And so when we are doing Desmos, you're going to click here. You can put y equals, but you don't actually have to. But what we're going to do is we're going to do the same two graphs that we did before. So back on this paper, I'm going to type in y equals 3 to the x power, and then I'm also going to do y equals 1/3 to the x power. So let me go back to Desmos here. And so our first one was y equals, and we were doing 3. And then you might be thinking, well, how do I do an exponent? Well, down here, you're going to click on this little keyboard. And when you click on that keyboard, you have all these fun options here. You're going to pick the one that says a to the second power. And when you push that, here is what pops up. Well, click right next to the 2 and do a backspace and make it an X. And look what happens on your graph. This is the same graph that we just put on our paper. I can zoom out and you can see it just keeps going and going and going. Now on our graph, we were at 0, 1. We also had the point, this is by 2, so it's going to be a little harder to see. But we had the point, let me find a good one here. All right, I want to get to 2, 9. There it is. Okay. And it just kept going. Now over here, if I click on a bunch of these little ones, look at the y value. See how it's 0.01 for the y? If I click over here, it says 0, but that's because Desmos doesn't have the ability to do the long, really, really small decimal. But notice it just flattens out. It doesn't actually ever go below the y-axis. So now over here, we're going to do the second graph. So I'm going to press this plus right here. It's going to give me another option. I'm going to do expression. Okay. And now I'm going to do again y equals, but the second graph that we just did was 1/3 to the x power. So I'm going to do parenthesis, 1, and then you can do the division sign or the backslash, doesn't matter. And it was 1/3. And then I'm going to close parentheses and I'm going to press this a squared button again. But I don't want the exponent to be 2, I want it to be an x. And now let's shift over to where our graphs are. We'll look at that. They are just mirror images of each other, and those matched exactly what we just put on our paper. They both had a y-intercept at 0, 1. And then when we were at 2, 9, right there, 2, 9 for our 3 to the x power graph, we're also at -2, 9 for our y equals 1/3 to the x power graph. So one thing that's going to happen is we're going to be able to graph these and then check our work on Desmos. That's the best thing you can do is after you make your table of values, you plot your points. If you're wondering, am I doing this graph correctly? Well, you can plug the function into Desmos and you can check your work. Okay? All right, so we're going to do 2 more examples. The one thing we haven't seen yet is, well, what if the a value isn't a 1? Like, for example, what if we did the following? What if it was y equals 2 times 2 to the x power? Well, now when we make our t-chart, we have x, we have y. I'm going to pick the same numbers we did before. But now, when I plug in all these values for x right here, and I do 2 to that power, after I calculate this part of it, then I have to multiply that value by 2. Okay? So it looked like this for the first one. 2 times 2 Alright, so as I was saying, what we can do is we can use these same 5 values, and we're going to plug them in one at a time for the exponents. Well, if I do 2 to the negative second power, that equals 1 over 4. If you multiply 1 over 4 times 2, that gives you 1 over 2. And then if you do 2 to the negative 1 power, that gives you 1/2 times 2 gives you 1. And then 2 to the 0 power, anything to the 0 power is 1, times 2. That gives you 2. Do you see a pattern now? These numbers are doubling. 2 to the first power is 2, times 2 is 4. 2 to the second power is 4, times 2 is 8. And there is your exponential growth. So now I'm going to plot these 5 points. I can fill in my t-chart over here. So I had 1/2, 1, 2, 4, 8. The big difference is, look what happens when x was 0. Your y-intercept is now 2, which matches your a value. Your a value is your y-intercept. So when x was negative 2, we were at 1/2. When x was negative 1, we were at 1, 0, 2, 1, 4, and eventually 2, 8. And there is your graph. Now, when it comes to, well, does anything really change? No, this is just like the graph that was y equals 2 to the x, but it's shifted up one spot because of your your a value changed, so your y-intercept changed. But when it comes to domain and range, it's still all real numbers, and your y's are still greater than 0. Now, we're going to do one more example. What if the a value is negative? So what if we had y equals negative 2 times 2 to the x power? Now this changes everything slightly. If this number right here is negative, if your a value is negative, now your graph, instead of occurring above the y-axis, is actually going to occur below the y-axis. So we're going to make our t-chart with our table of values, find our y points that go with our x values, and plot them. I'm going to make the t-chart really quickly. So I went ahead and did the table of values to save us a little bit of time, and notice the resemblance of this table to that table. What's the only thing that changed? All the y values became negative over here because my a value was negative. And so if my y values are negative, all of these occur below the y-axis. So now when I go negative 2 for my x, I go down 1/2. Negative 1 for my x, I go down 1. Then I go from 0 down 2 for my y-intercept. When I go right 1, I go down 4, right 1, down 4, and eventually right 2, down 8. So now you look at that graph, look at that. That's what it would look like if your a value is negative. Now for your domain, still all real numbers. I can plug in anything I want for the x. But now what's different about your range? Well, over here, everything was above the y-axis. Everything here is below the y-axis. So now my range is y is less than 0. All right, now let's go ahead and check these graphs on Desmos. So the first graph that we just did was y equaled, and I can change this to a 2, and it was multiplied by 2 to the x power. That is going to be the blue one. This red one's going to change once I change the numbers over here. Our second one was negative 2 times 2 to the x power. And so I'll shift my graph up a little bit so you can see it. These are the two graphs that we just did on our paper. They're just on the same coordinate plane at the same time. So again, after you make your table, you plot your points on your graph, you draw your curve, you can check your work in Desmos, which I highly encourage you to do, especially on the assignment that you're about to do right now for 6.3. Okay, hope that all made sense. I hope you watched both videos and learned a lot about exponential functions. See you next time.